Hey guys, we are going to go through chapter 10, section 10, which is on reflections. This is our last section being in chapter 10. Yesterday we talked about translating shapes, so rotating them. Today we're going to talk about reflecting them. I am sorry if I sound stuffy or sneeze throughout this because pollen and allergies are getting to me a little bit. So I apologize in advance. So looking at some new keywords that you're going to need to know during this. For the first part, there's kind of two parts to this lesson. So the first part is a line of symmetry, or just line symmetry. So what that means is if figures match exactly when they're folded in half. So if I have an exact square and I fold it in half, there's line symmetry in that. If I take a circle and fold it in half, it should fold in half and the sides should match exactly. If I were to take something that is kind of a different shape and fold it in half, anything that's like square on one side and a circle on the other, it wouldn't have a line of symmetry if I were to necessarily fold it in half. So we're going to look at a couple examples just so you have a little bit better understanding of these words. And there are some examples like this in your homework where it'll just ask if they have a line of symmetry or not. So looking at this, you are determining if each figure has a line of symmetry. So if you can fold them in half. So folding them in half can be either horizontally. So like with the E, I could either fold it in half long ways or up and down. In some shapes, it can be both. For the example of the E, if I were to fold it in half, so if I were to fold it down the middle like this and like flip this side to this side, they wouldn't be the same if I were to flip it that way. But where an E does have a line of symmetry is down the middle. So if I were to flip the top to this side, it would fold over and be the same. So the E does have line symmetry. If I'm looking at the letter G, if I were to fold it in half this way, the top doesn't match the bottom. If I were to fold it this way, the left side and the right side don't match. So this shape does not have symmetry. And then the H, if I fold it across, so I fold it this way, it has a line of symmetry. But also if I fold it up and down, so if I fold the top onto the bottom, it also has line symmetry that way. So to represent if it has line symmetry or not, you simply just draw a line where it would. So I'm going to erase all the arrows really quick just to show you what you would have in this case. So the line of symmetry in the E would be here, and then in the H, and it should really be more right here, and then also in half. And then the G wouldn't be symmetrical, so there's no shape, or so there's no line of symmetry right there. So then looking at what we're really getting into, and this is the title of the lesson, is reflection. So this is very similar to yesterday with writing the new coordinates when you translated a shape, except for now you're writing the new coordinates or vertices when the shape is reflected. So a reflection in math is what you think a reflection is. When you look in the mirror, you see your reflection. It's really a mirror image of the original figure. So if you've ever like held something up in the mirror, you notice it's backwards. That's kind of the same concept here. So there are two ways that you would be asked to reflect a figure. So you will either be asked to reflect it over the y-axis or over the x-axis. So this is important to look for. So this is the x-axis. So if I'm reflecting a figure over the x-axis, that means I'm flipping it that way, or I'm reflecting it that way. So my shape is going to go down and over the x-axis. So I'm not translating it, I'm literally just like flipping the shape over. So it's going to, and I'm not gonna draw it exactly, but if I have a triangle that looks, let me draw that a little bit better. If I have a triangle that looks like this on the top of the x-axis and I'm reflecting it, it's going to be the opposite way. So it's literally reflected. So with translating, if my triangle looked like this, it still looked like that, it was just moved. So with reflection, it's now kind of flipping over, if you want to think about it that way. So what I'm doing, and I'm going to look at point A first. If this is 5, 2, I'm reflecting it the opposite way. So I'm still going over 5 and then going down 2. So this is my new A for my second shape. Then for B, I was at 1, 3. So I'm still going to go over 1, but now I'm going down 3 instead of up 3. And then for my C, I was at -1, 1. So I'm still moving over -1, but instead of moving up 1, I'm now moving down 1. So this is, and it's not gonna, so it's a reflection of itself. So if I were to like cut those two triangles out, they would be the same. And I could flip them and reflect them on top of each other, and it would be the same. So that's kind of where the line of symmetry comes in, is that they're the same shape when I kind of unfold it, if you want to think about it that way. So it's asking you to write the new coordinates. So all you really did, you didn't change your x's in this case, you only changed your y since I was reflecting it down. So my A is still 5, but instead of +2, it's -2. My B, I still went over 1, but instead of going up 3, I went down 3. And then my C, I still went over -1, but instead of going up 1, I went down 1. So my X coordinate stayed the same. The only thing that really changed was my Y coordinates. So then the next example we're going to talk about is then reflecting a shape over the y-axis, which means kind of the opposite. So I was reflecting this way before over the x, so now I'm reflecting over the y. So my shape is going to move from here to over here. Okay. So again, same thing. I am looking at my coordinates. This one's a little bit different. So now what's going to change is my x instead of my y. So if I look at K, I went over 2 and then up 3. So I'm still going over 2, but I'm going over -2 now. And then I'm still going up 3. So my K now is -2, 3. My L, I went over 5 and then up 1. So I'm now going to go left 5. So my L is now -5, and I'm still going to go up 1. So over 5, up 1. Then my M, I have 4 and then down -2. So now I'm going to go over to -4, and I'm still going down 2. So now this is -4, -2. And then my N, so instead of it being 1, -1, I'm going to go over 1 to negative and then go down -1. So my N is now -1, -1. So those are my new coordinates. And if I were to, ooh, that was a really bad line. Still a really bad line. It's much harder to draw this on a computer than you guys would think it is. Okay, there we go. So this shape is reflected. So if I were to kind of fold it back over, it would land directly on top of that shape, but also be exactly the same shape. So pay attention to if it's asking you to reflect over the Y or X. All you're really doing is making the new coordinates, they're going to stay the same. They're just going to change from positive to negative or negative to positive, depending upon if you're flipping over the X or flipping over the Y. You could get it where your shape starts over here and you need to flip it this way, so then it would have been the opposite. So if it started at -2, 3, it would then change to +2, 3. So it would be the same thing going the opposite way. So if you guys have questions on this, let me know. Most of you did really well with translations and renaming the vertices. So this should be very similar to that. But if you have questions, let me know. I will be more than happy to answer those for you. And I hope you continue to have a great week. Miss you guys. Bye.